Good morning, dear students. In today's class, we will be seeing the angular momentum of many electron atoms. We have seen that electron possess both angular momentum, orbital angular momentum, and spin angular momentum, and both of these quantities are vector quantities. And in the last few classes, what we have seen is a system which is having only one electron. In case of hydrogen, there is only one electron, and in case of sodium, the valence shell contains only a single electron. So these systems are considered as one electron systems. Now we will assume that we have a system in which we have an atom in which the valence electron contains more than one electron. So in that case, how to calculate the total angular momentum of the atom as such. So in case of one electron systems, the angular momentum of the atom is the angular momentum of the electron itself, whereas in case of many electron atoms, you have to use a special method to find out the angular momentum of the atom. So there are two methods to find out the angular momentum. One is known as the LS coupling scheme or Russell-Sanders coupling scheme, and the other one is known as the JJ coupling scheme. Usually LS coupling scheme applies to lighter nuclei and JJ coupling scheme applies to heavier atoms. So usually in case of atoms, only the valence electrons will be contributing towards the angular momentum, and all electrons making up complete subshells of electrons are so quantized with respect to each other that their resultant angular momentum vanishes. So we will be looking only for the valence electron. So suppose you have a 2 electron system, that means there are 2 electrons in the valence shell. Then if you want to calculate the total angular momentum of the atom, then either you can go for a LS coupling scheme or a JJ coupling scheme. In LS coupling scheme, what we are doing is the individual orbital angular momenta components we will add, and then the S components will add. This will give you a capital S value, and the other one will give you a capital L value, and this capital L and capital S will combine to give the total angular momentum. In JJ coupling scheme, little l1 and little s1 combine to give a little j1 value, and then this j1 j2 will combine to give the capital J value. So these are the two different schemes for coupling, and we will have, in order to have a better understanding of this coupling schemes, we will do some problems. So I have given some homework to test your understanding of the subject. So please do it and submit it before Monday, or at the maximum by Monday you can submit. So this topic is very important for competitive exams like UGC, GATE, all these exams. So try to have a better understanding, and if you have any doubts, feel free to ask. So we will go directly to problems. So first, in LS coupling, what happens is L and L couple to give a resultant capital L, then S and S couple to give a resultant S, and then capital L and capital S will give you the total J value. So we will have a look at the LL coupling first. Suppose you are considering an atom which is having 2 electrons in its valence shell. Now we assume that both the electrons are in the p state. Then L1 L2 coupling gives the following values. Here L1 is equal to 1 because L1 is equal to 1 for a p electron, L2 equal to 1 again p electron because both the electrons are in the p state. Now L will be having values from L1 plus L2 to L1 minus L2 values are possible. That means 2, 1, 0. These are the possible values of L. So 0 stands for an S state, 1 stands for a P state, and 2 stands for a D state. If one of the electron is in P state and the other electron in the D state, here that means P state you have L1 is equal to 1, and for the D state you have L2 equal to 2. That means capital L will be 2 plus 1 3, 2 minus 1 1, 3 2 1. These are the possible values of capital L. So 3 L equal to 3 is F state, L equal to 2 is D state, L is equal to 1 is P state. Now let us consider the third example in which L1 is equal to 1. 1 is nothing but a P electron, and the second electron is situated in the F state. So capital L will be having 4, 3, 2. So the states are G, F, D. Now if L1 is equal to 2, L2 equal to 2, then L can have values 0, 1, 2, 3, 4. That means S, P, D, F, G. These are the possible states. Now similarly, L1 equal to 2, L2 equal to 3, L will be having 5, 4, 3, 2, 1, H, G, F, D, P are the state. Now using the LL coupling scheme, we are going to construct the states corresponding to an states in that one of the electron is in the S state and the other electron can vary from P, D, F, etc. So first we will consider both electrons are in the S state. S dot S actually indicates the same type, indicates that they have different total quantum number, because no two electrons can have all the 4 quantum numbers identical. Now S equal to both electrons are in the S state, therefore L1 equal to 0, L2 equal to 0, capital L will be 0. So this corresponds to an S state. Now we assume that one of the electron is still in the S state and the other one is in the P state. Now in that case L1 equal to 0, L2 equal to 1, that means L equal to 1, that is nothing but a P state. S, D. In this case L1 equal to 0, L2 equal to 2, that means capital L is equal to 2, this corresponds to a D state. S, F. L1 equal to 0, L2 equal to 3, so that L is equal to 3, this is F state. Therefore S dot S actually gives S, SP, P, SD gives D state, SF gives F state. Now in a similar manner you can have write the terms for the P electron. One of the electron is always fixed in the P and the other electron, second electron, is in the S state. In that case you will be having a P state, and if both the electrons are in P state then you will get SPD. This you work out by yourself and verify whether you are getting the same result. And for PD, PF the results are given. In a complete, as a homework you have to do the following. Complete the LL coupling for the valence electrons in the following state. One of the electron D, then the other electron S, P, D, F, and for all these 4, and again FS, FP, FD, FF. You have to write the terms and then the corresponding capital L values and then send it to me. Now we'll look into spin-spin coupling. Suppose S1 equal to half, S2 is equal to half, then the capital S will be either 0 or capital S can be 1. 0 means both are aligned in the opposite direction. This will give you a resultant value S equal to 1. So now you had 2 electrons and these 2 electrons, one was now you understood how to couple the angular orbital angular momenta as well as the spin angular momenta. Now we will go for a LS coupling scheme. Suppose that one of the electron is in the a p subshell, that means L is equal to 1, and the second electron is in the d state, that means L2 is equal to 2. Now L1 L2 coupling gives L equal to 2 plus 1 3, 2 minus 1 1, so 3 2 1 FDP. SS coupling, SS equal to S1 is equal to half, S2 equal to half, that means the capital S value can be either 0 or 1. Now we'll go for the LS coupling scheme. S equal to 0, L equal to 1 2 3. So since S is equal to 0, J will be the same as that of L. So J is equal to 1 2 3, and there is a term known as multiplicity, that is nothing but 2s plus 1. So when S is equal to 0, the multiplicity will be 1. This state is actually known as a singlet state. If S is equal to half, then the state is a doublet, and S is equal to 1. In that case, the state is a triplet. So now we can write the term symbols corresponding to this state. So we got for S is equal to 0, L equal to 1 2 3, the term symbols are 1 P1, 1 D2, 1 F3. L equal to 1 P state, L equal to 2 D, L equal to 3 F. J values are 1 2 3. So all the states, and all these states are singlet states. Now what is left out is, now we have to find out for S is equal to 1 what are the values of possible values of J. So S is equal to 1, there are 3 possibilities for each of the 3 L's. That means S is equal to 1, L equal to 1, then L plus S2, L minus 1 S values are possible. That means 1 plus 1, that is 2, 1, 0. So S is equal to 1, the state is a triplet state, that's why this 3 comes here, 3. L equal to 1, therefore it is P, and 0, 3P0, 3P1, 3P2. These are the 3 term symbols corresponding to S is equal to 1, L equal to 1. Now S is equal to 1, L equal to 2, the J values will be 3 2 1. So 3D1, 3D2, 3D3. S is equal to 1, L equal to 3, J values will be 4 3 2, 3F2, 3F3, 3F4. Thus the LS coupling terms arising from the interaction between a P and D electrons can be summarized as follows. P electron and D electron will give you 1P1, 1D2, 1F3, then 3P0, 1 2, 3D, 1 2 3, then 3F2 3 4. So these are the 3 singlet states. So this corresponding to L equal to 1, the states, all these states corresponds to L equal to 2, then L equal to 3. Now as a homework, if you understand the subject as a homework, you write down the term symbols arising from SP, SD, SF, PP, PF, DD interactions. So first, one of the electron is in the S state and the other one is P, S and D, S and F. Then both electrons are in the P state, and one electron is in the P state, F state, and DD. So first you have to write the capital L values, then the capital S values, then the capital J values, and you have to present something like this PD. And as I have shown here, you have to present. So hope you are studying, and thank you for listening me. If you have any doubts, feel free to ask.